Guys, on these, sometimes people get messed up because you kind of get locked in on star, and you need to be flexible in how you solve. So what's the best way to do that first one? What was it?
We divided by 144 and squared.
Yeah. Why are we square rooting and not factoring?
Because there's no
Yeah, that's what I meant to say, square rooting, because that's what I did. Was square rooting.
There's no bx term. So don't forget to write the plus or minus, please. There are two roots. Can you please? Same thing here. Are they always going to be this nice, perfect square stuff? How about this one?
You would divide by 2.
No.
No. But you would.
How many of these did you do?
What?
How many of these did you do?
First
Okay.
I did all of them.
Because we need to get this set equal to 0.
Oh, yeah. I knew that.
There's a bx term, it says y in this case, but it's bx term. So when you see that, set it equal to 0 so that you can either star or quadratic formula, or completing the square. We'll learn that probably Monday. Anyway, there's no GCF. Don't forget to check for a GCF. And let's try to star this. We're looking for factors. Remember, A times C goes on top. In this case, negative 90. B goes on bottom. In this case, negative 13. A on the top of the sides. So factors of negative 90 that add up to negative 13. What was it? So negative 18 and 5. Then we need to make sure the two sides are simplified if they can be. This side is good. So it's just going to be 2x plus 5. This side needs a little work. Both can be divided by 2 to get 1 and negative 9. And then those go in also. Alright, and then we split and set each one equal to 0. So our two zeros are what?
Negative 5 halves and positive 9.
Okay. How about this one? That one looks kind of weird. Are our two zeros just 8/3 and 1?
No.
Why?
We still have a 3x.
It's not set equal to 0. So we need to distribute and combine first. So expand these two, like multiply them out. Okay, then we'll get negative 11x and then minus 3x when we combine. Is there a GCF?
No.
Always check if there's a GCF. So back to the star. I'll just write it over here this time. Okay, are there factors of 24 that add up to negative 14?
12 and 2.
But
Both are
negative. Both negative. Alright, simplify if possible. This side is good, the right side. So we get 3x minus 2 from that side.
And x minus 4.
Those can be simplified by 3.
X plus 4.
No. Not for our factor. Because if I divide this by 3, it's 1. If I divide that by 3, it's negative 4.
Yeah, and then you plug it.
Alright, so this is going to be 2/3 and 4. How'd that one go for you? Raise your hand if you got that one right. 2/3 and 4.
Wasn't it like 2/3 that I did?
You got what?
I got the 4.
Just the other side you did?
Yeah, cool, because I did quadratic formula.
Okay. Did anybody do this one?
It wasn't on the That was on the screen.
Oh, it wasn't on the screen. Okay. Anyway, it's the same exact thing we just did. How about this bottom one? I know you didn't do it, but just look at it. What would you do there? Same thing, right? Except for on the other side, we just have a constant instead of a bx term. All right, how are these going?
Pretty good.
Here's one that's cubed. Why don't you take a look at that one and solve it real quick?
Is the other one?
Which one?
too?
No, here on. Oh, thank you.
Wait a second.
That's a 3. And this is a 2.
Wait a second.
Okay?
Me thinking me got it right.
So your first step needs to be set equal to 0. Just like always. What is your next step?
Divide by 2.
GCF, right? Always check for a GCF.
Technically, I did this job. Oh, I know.
So in this case, 2y is our GCF. That 2y is a big deal. Why?
Oh, because you can get rid of.
Okay, do we just like toss this off?
No.
No. Put it out front because it is a factor.
Oh,
And if you just ignore the 2y, you are missing one of the roots, one of the solutions to this. This is called a cubic polynomial. We'll do more with them in the next unit, but we can solve it just as easy here if we want. What is the 0 of the 2y factor?
1 plus 1.
Okay, so we need to get this concept right now and never forget it the rest of your math life. When we talk about zeros, what do we mean by that? Don't say x-intercepts. They are that, but I'm not asking graphically. I'm saying what is a 0 of a function?
When the y equals 0.
Say it again.
When the y equals 0.
It's when the y value of the function equals 0. The output f of x is 0, right? Okay. So when we solve for zeros, we solve for values of the independent variable that make the function 0, right? That's why they're x-intercepts. But, so again, how, maybe I'll pause there and ask this question in a second. Let's figure out the rest of the factoring. I hate it when it does that. 2y stays out front. What is this factor to be? 4 minus 1. 4, I need a y right there. 4y minus 1 and 4y minus 1. Guys, this is a perfect square trinomial. 16 is a perfect square, y squared is a perfect square, 1 is a perfect square, and 8 in the middle is the sum of them. Sum of the two bx terms. So it's a perfect square trinomial where both terms are the same. Does everybody see that?
We're gonna have to go back and how to get the thing.
Well, just star it if you don't know. You can always do that, right? This is 16, negative 8, and 16 here. Well, factors of 16 that add up to negative 8 are negative 4 and negative 4. Simplify those, and you'll get 4 and negative 1.
I haven't got it.
Right? I mean, star, it's not that star doesn't work. It's just you can save yourself the time if you recognize it's a perfect square trinomial. So, squared, 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 sum of two bx terms, the same two bx terms. Anyway, how many factors are in that list right here? How many factors are in that list? Hold it up. It's 3, right? Okay? So each one of these creates a 0. In other words, if this is 0, what is 0 times these two factors?
0.
It's 0. Okay? If this one is 0, what is 0 times the first and last factor? 0. If this one is 0, what is 0 times those two?
0.
Okay, so we have to find the spot where each of those becomes 0. That's what we've been doing the whole time, right? When you star factor, that's what you do. When we did this little step, that little step, what you guys have called split, you're saying where does this factor equal 0? Well, it happens when x is 2/3, because 2/3 times 3 is 2. 2 minus 2 is 0. That makes this 0. 0 times whatever that is still 0, right? Okay, and then the other side, if I plug 4 in here, 4 minus 4 is 0. 0 times whatever this is 0. So we're finding the two places that make, in this case, the two numbers that make these two factors 0. So it's 0 times and 0 times. Okay? That's called the zero product property. So we still have to do that here. We're still trying to figure out where each one of these makes the function 0 this time. Okay? So where does this one make the function 0?
1/4.
Yeah, 1/4, right? Set that, like ignore all this, move the 1 over and divide by 4. So if I multiply 4 times a fourth is 1, 1 minus 1 is 0. That's the same here, right? Yes? So 1/4 is one value. Now next unit we're going to learn that means that has a multiplicity of 2. It shows up twice in our list. But it's just still 1/4. It doesn't change that. Okay, this one, let me erase this now. 0 at least. Okay, how do you make that first term 0?
So y equals 0.
Yeah, it's just 2y equals 0, so y has to be 0. I put an x there, I need to rewrite it as y. So that is a really important piece to not just drop because it's a 0. In fact, it would be if we're graphing, we would have this 2y would be a 0 on the origin, and then we would have the other one right past that, just barely at 1/4 over. Okay, so we have those two zeros. And a is positive, so this thing would do this. This is exactly how this graph would look. Bounce off there and then come back up through. Okay? No, sorry. I bounced it off the wrong thing. Hold on. Bounce there and up. Okay? So that's a cubic graph. But those two zeros are really important. Okay? Are we understanding where zeros come from? Where do they come from?
Where x is 0.
Each factor makes the function 0. Or each, if we're doing the quadratic formula, it's where you can't really call those factors, but it's where those make the whole function be 0, right? Okay, let's just do another one just to make sure this is good. So we're setting it equal to 0. What can we do first? Yes, divide out of 4. Okay. Can this 4 be a 0?
No.
No, that wouldn't make sense. Can I ignore the 4?
Yes.
Yes, because I can't say 4 equals 0, right? That doesn't work. Why can I ignore the 4, but I could not ignore the 2y?
Because there's the y there.
Yeah, it had a variable. Okay, so we can just factor this inside piece. You're going to get x minus 7 and x plus 3. Now I'll leave the 4 out here because that's factored form. We're going to talk about that here in just a bit. This is factored form of this standard form polynomial, or quadratic. Where are the two zeros? Well, 4 isn't one of them. But if this is 0, value of x makes that so?
7.
7, right? So at x equals 7, that would do this version. That's 0 times 4 times 10, which is 0. Okay, what makes this one 0?
3.
If this is -3, this whole thing is 0, then -3 times 0 times -10 times 4 is 0. Make sense? Okay. Try to understand what's going on behind the scenes. I think it will help you do the process better. In fact, grab your notes and let's make sure, because before we do intercept form number 3, we need to really understand what solving a quadratic means.
Mr.
Yeah.
Will we have any imaginary figures with quadratic?
Don't take all I heard.
Oh yeah.
How much are we gonna do?
A lot.
Okay.
Well, I guess I don't know what you call a lot. Like, you're gonna learn all about it.
Yeah, this one has some exercise. Yeah, so the functions.
So no, nuns.
The functions.
So you're finding the x values where the function value is what?
0.
Okay. How? Now, what if it's a quadratic like this? Maybe it's a quadratic linear system. So just pause and think with me for a second. 2x squared plus 4x minus 10 equals a linear equation. Something like that. Turn that off, please. So minus 4, positive slope of 3. This is opening up. The vertex is at 1. -1 rather. I'm going to extend this somewhere. Okay? So maybe this thing comes down and does that. What are we solving for in that case?
The intercept of both lines.
We're solving for the points of intersection, just like always, right? Just like two lines crossing, we're solving for the points where these two. On your quiz from last time, we had a absolute value function and a parabola that intersected 2 times. Okay, I had you scratch it out, but it was on your review. Okay, that's this. But if I said solve this system, now that you know what you're looking for, it's technically not the zeros. It's technically where those two things intersect. But how would you solve that? Yeah? Still set it equal to 0. Okay? You would just subtract 3x and add 4. And then solve from there. So it's, even though we were not going to actually find zeros because of the way it's set up, it's still the same idea because we set it equal to 0. Questions on that? That was called a quadratic linear system, right? Because we have lots of options. Like maybe the line is this way and our parabola does this. And we're looking for those 2 points. But really we just set them equal to 0 and solve like normal. And it will tell us where those points of intersection occur. Okay. So we need to understand this. This is why we're writing this note. So we're going to use the 0 product property. which basically says this is kind of the casual version. If things are multiplied to make 0, at least one of them must be 0. Can I multiply non-zero terms to get 0? Is there any way to do that? No. The only way to multiply things and get 0 is if something is 0. Okay? This is not the same idea as what we do when we find zeros with the quadratic formula. We're not using the zero product property. Okay, so the result of this so you're going to set every factor that has a variable equal to 0 and solve each. I don't want you to memorize a recipe. You guys are in an accelerated, more advanced class. You need to understand how math works. Okay? Not just memorize a recipe. Don't be that kind of a math student. It seemed like people had some trouble with 30. Should we do that one? Oh, seriously, it's because it's got words in it.
I kind of forgot how to do it.
This is math, not English.
Oh, brother.
That's true. There shouldn't be letters in that.
Life is full of words, not numbers. To communicate.
I mean, technically, it's a computer. At the same time.
Well, but you know what I mean. You can't communicate with somebody in just numbers.
You could. You could set it up.
6, 9, 8, 0, 0, 8,
Well,
5.
duh, but words and math should not be mixed.
All right. Why is this different than what we saw when we're throwing stuff?
Because it's wrong.
Or is it? Maybe it's not. It looks different. There's only 2 terms instead of 3. Why? Do you guys remember what we talked about yesterday?
Because.
It's just dropped. There's no initial velocity, right? It starts at 0 meters per second or feet per second. You could have figured that out even if it didn't say dropped. Just because we can tell this is gravity and this is the initial height, there is no initial velocity. Okay? Yeah.
So then, if somebody's throwing something, would the initial velocity be how fast their arm is moving while they're throwing it?
No, well, technically yes, but I mean we're measuring the initial velocity of the object leaving their hand, which is probably pretty close to their hand. But you know, like if you throw a baseball, you get that stretch in your fingers, which springs it a little bit. So your whole arm is not moving that fast. But all right. Anyway, how long does it take for the penny to reach the ground? We did a talk through a version of this where we were actually solving for the height instead of the time, because we can measure the time in most cases and not the height. So how you guys, you can tell most of the book problems use y and x, but really it's better to use variables in context. So what's a good equation modified to make sure this references our variables.
X could be like T for time.
Okay. What's our dependent variable?
Y.
Y doesn't tell us anything.
Dropped maybe?
Still height, right?
Yeah.
It's like how high is this thing each moment? What is the 16 doing to the penny?
That's how fast it's moving due to gravity.
It's gravity. What is it doing to the penny?
Making it fall.
Increasing its gravitational
How much?
Uh,
It's accelerating it. 16.
feet per
Actually,
second.
it's 32 feet per second every second.
Yeah.
So after 1 second, how fast is it going? 32 feet per second. After 2 seconds,
Double that.
64, etc. Right? Anyway, it says, how long does it take for the penny to reach the ground? So what are we solving?
Oh, okay.
What are we solving for? That t right there.
Not X.
Okay? What's the height when it reaches the ground?
This is so easy. Why do people have issues with this?
So let me write it out and then we'll solve it.
Boring, but it's so easy. Literally, all you have to do is plug in certain numbers for T for a little bit.
Seriously? You're not going to solve it algebraically? Guys, let's reverse this just so we know our variable is on the left side. Alright, what's 256 divided by 16?
16.
16.
Duh.
Square root is 4.
The square root of this.
Alright, remember when you solve one of these quadratic functions, you get two answers, or should, not always, but should. With these kind you do. These kind meaning when you square root. So which one do we use?
The positive in this context, because you can
Okay.
have negative time.
It took negative 4 seconds.
Why don't you graph this, please?
No, over.
Okay, this graph
No.
starts where?
256.
So this table is like.
Okay, but remember in terms of the math, it's got that other arm of the parabola. And that's our -4. And then 4 on the other side, that's our what? What are those called? Those are called zeros, right? Those are zero height. Why would the math tell us that there's 0 height 4 seconds ago?
Because we're starting at 256.
Yeah. Okay, vertex then is at 0 to 56. That one was easy because b is 0. Right? No bx term means b is 0. If you plug 0 into this, you get 256. That's a quick solve. Are you guys with me?
Yeah.
Okay. Domain, what's the domain? So time is infinite in this problem?
No.
It's like
Negative 4 is 4. No.
Holy moly.
Negative 4.
It'd be 0 to 4.
Thank you, Tom.
My brain's just tired.
0 to 4.
Oh.
Because the other- the other
Why
part
is
is
it 0 to 4?
Because time can't be negative.
Well, it can. Is it in this case?
Because it
It's
started
not
at the
asking for it
building
to be.
Because
and
it's
it
con.
ended at the ground.
Yeah, the time started as soon as you let go of the penny, and then it stops when it hits the ground. Like after that, this doesn't have any meaning. How about the range?
0 to 2.
0.
What if we were doing imaginary?
There aren't any in this problem.
How can you?
There's no imaginary numbers to talk about in this problem. It's all real. But do you?
I was just thinking that the -4.
No, that's a real number. The -4 is a real solution, limited out of the domain by context. But mathematically, it's totally fine. Yeah, good thought. How you doing with this stuff when we start putting it all together?
I can work on it.
I feel like
5 out of 5.
once you like explain it, it clicks.
Yeah, I've done that a lot of times now, so it needs to click without me saying something.
We should
Are
have
we
a,
getting there?
yeah, we should have a test of
Yeah.
just this.
Okay, so I have a question. The plan was to have a quiz tomorrow. The content after the quiz is complex numbers, which is the imaginary stuff. Completing the square. You guys have done, you've done the quadratic formula, so I suppose we could just review it. That also falls after the quiz, but you've done it, so it's not new. It will be short. So our other option is just to wait and take one assessment on this whole unit, or do you want to do a quiz tomorrow and then see that stuff again probably next Thursday on the test?
Yeah, assessment.
Quiz tomorrow. Okay.
When will the test be next week?
Can we just not do this?
Tomorrow you'll have the first half of the class roughly, maybe 55 minutes somewhere in there to do the quiz, and then we're going to start the complex numbers. Finish complex numbers Monday and start completing the square. So probably Thursday.
Let's go.
Why?
I had that.
I'm not gonna be this week.
Okay.
Final.
It won't be Friday. We'll be done with it by then. Then we'll start the next unit. It could. I suppose we could get there Wednesday, possibly.
When?
Wednesday. Who all is? You're going on the field trip for chemistry, and you.
Yeah.
Anyway, all right. So plan on a quiz tomorrow then.
Why?
I hope this goes well for you.
It's
Factor
so
form.
easy to for you want the
I don't
extra
care if
credit.
it's easy. I don't want a second assessment.
He's saying it's easy.
Factor form will be on the.
I don't think
Yeah.
it's easy. I'm saying.
Why can't we just have one big
Make the test.
Factored form. Listen up. I might just have to show you. Anyway, we talked about that. Cool. So lots of solving. Go, 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 go. All right. I just wanted to remind myself what's coming up. I think, let me show you factored form and then we'll try a couple of these, like that one. And I think you'll be fine, but grab your notes, let's write factored form. This is the last form that we'll write. A lot of times you'll hear it called intercept form. But it's also called factored form. Why did I put those quotes right there? They should have gone right there. Guys, what does vertex form tell you right away?
The vertex and
The vertex. What does standard form tell you right away? Which isn't very useful. Have you figured that out? In most cases, it's not very helpful, at least not for graphing.
Unless it's in context.
Yeah, and in context, it does help because it tells you where the thing started. Or, well, typically that's what it tells you. So, just to guess, what do you think this form's going to tell you? The x-intercepts, right away, yep. Good job. Here's what it looks like. We have this a value out front, just like always. We're introducing some new letters. Sorry, but we are. P and Q. That is intercept form.
My Q's look like 9s. They
Yeah.
look like 9s with tails.
Everybody's does.
Well, 9 with a tail is
Okay. To try to concentrate on this, since it's new, your two intercepts So let's write them as points, I guess. 0p. I wrote it backwards. Let me fix it. P0 and Q0.
Does A mean the same as?
Yeah, we'll write that. Good job. So, guys, like you said, you knew exactly what it was going to tell you. It tells you that x-intercepts are the zeros right away. As long as you know to solve these for the 0, right? Just like we talked and put in the note right before this. So use the 0 product property, set each factor to 0, and then that will tell you the zeros.
These ones will actually be useful.
A is the exact same as all the other forms. All the things it tells you, which are what?
Over 1, over 2.
Graph pattern, what else?
If it's, negative.
Positive or negative.
Concave.
Concavity, what else?
Vertical and compression.
Vertical, stretch, and compression, good. Yep, those things. Do you remember all that?
Yeah.
A is 2, what does it do?
Over 1 up to
Vertical stretch by a factor of 2 and concave up. A is negative 1/2.
is concave down,
Concave.
vertical.
Still a vertical compression.
Yeah, where you stretch it.
So
A is always vertical. If you're dealing with A, you say vertical. It's a vertical compression. Okay. So that's standard form. Each form we have also talked about how to find the vertex. How do you think you do that in this one?
P and Q.
P and Q are intercepts. Okay, I'm going to give you a hint. If we sketch some random parabola and we have P and Q, you do have to use those, but it's not at P and Q, right? It's going to be in between them. So how could you use P and Q to tell you where the vertex is?
Find the distance.
Subtract the two, then you get the middle, and that's your vertex.
Well, you don't get the middle by just subtracting them,
Using the axis of symmetry.
but you have to know the vertex to find the axis of symmetry. But you guys are getting close to the idea. Huh? You don't have to do it that hard.
You add them together and then divide it by 2.
That's called the average, right?
Yay.
Okay, if we add these points and then divide by 2, it will tell us what's right in the middle. So that's what we call averaging the x-intercepts. That will give you the x-coordinate, and then the usual y-coordinate is just plugging that value in. Good?
Yep.
Okay.
Yeah.
So I think I'll leave this up here actually. X vertex equals P plus Q over 2. I'll write it as a note, but then you have a picture if you're following along. X coordinate is P plus Q over 2. How about the Y coordinate?
Plugging in X.
Yeah. Now it's a little awkward. No, I can't write this because it's not. It's this kind of disjoint, choppy form, isn't it? Like let's say x is 5, you're gonna have to do like 5 minus something, 5 plus something maybe times a. So you have to be careful. How about the y-intercept? Is it any different? How do we always solve for the y-intercept?
So X equals 0.
It is a little bit more work in this form though. So I'm going to say carefully solve for
No, I saw you.
Seem okay? Okay. So you'll need to be able to graph in this form and give key features like domain and range and all the vertex, all that stuff. And then, how would we solve for A? We've done that in each form now. So in vertex form, we plugged in the vertex and a point and solved for A. In standard form, we were given either 3 points or more, and we had to do a system of 3 equations to solve for A, B, and C. So how about in this form? Yeah. Use what? Yeah, just plug in both intercept values and solve for A with a point. You still need a point, right? Otherwise, if you only plug in P and Q, you'll have X and Y as a variable along with A, which is too many variables. So let's do a couple examples of things. And then, so there's your zeros, and then let's say it goes through the point, I don't know, how about 1, 5. So step 1 is to write generic intercept form. Step 2, fill in P, Q, X, and f of x, which is just y. This is very similar to vertex form, isn't it? Okay? What is f of x? 5. What is x? -1. What is the other x? 1. What is p? 2. What is q? -4. Okay, and then we fill in all this stuff around it. Guys, the x-intercepts are p and q. The form says minus, but you have to plug in the given sign. So 2 is positive, plug it in as positive, write the minus sign in front. Q, or this 4 is negative, write -4 and put the minus sign in front of it. Make sense? Okay, step 3, solve for A using, I'm just going to say solve for A. At this point, that should be a formality.
This makes sense, actually.
Okay. So 1 minus 2?
-1.
-1. 1 plus 4? 5. Okay, and then A still stays for now, it's just A. And of course our 5 on the other side. Okay, what does this become?
-5.
Okay,
Oh, wait.
so this becomes -5A and 5, so what is A?
-1.
Okay, and then we're going to just like always, we're going to rewrite the equation. What do we plug in this time? Like before we had to plug in H and K, what do we plug this time?
A.
Just A? What are you going to say?
How did you get 5?
Kind of left, right?
That's the.
It came from here. It's Y. It's the point that the thing goes through.
What do you?
A, P, and Q, guys. Right? That's what defines the form is A, P, and Q. So f of x equals negative 1, x minus 2, x plus 4. How does that feel?
Really good, actually.
Yeah, this one's my favorite.
Does it seem kind of like similar enough to vertex form? Like the
Yeah.
process?
Yeah.
It's easier than vertex form, probably. Yeah, maybe
Oh,
not.
yeah, by
Maybe
now.
it's about the same.
No.
Okay, let's do an example of finding the vertex.
Okie dokie.
Sorry. I was not even what, actually.
Let's don't do 1, that's boring. Let's do 6. Okay, so we know the vertex is where? Well, the x coordinate at least.
So
What is P?
3. Negative 3.
What is Q?
6.
okay, it's not one.
Do you have a strategy that you're not going to mess up the sign of P and Q?
Yes.
Yes or no?
Yeah.
Everybody does? Alright, so x is negative 3 plus 6 over 2, which is 3 halves. Okay? Now what? Plug it back in for the y coordinate.
I just brought up.
So just solve with x plugged in. And so we get y equals negative 1/2 times 3 halves plus 3 times 3 halves minus 6. Can you do this without a calculator?
Sure. Yeah.
Because this is a no calculator section. So what's 3 halves plus 3?
11, 12 halves.
9 halves. What's 3 halves minus 6? Negative 9 halves. So we have lots, well, this is 12 halves, right? So 3 halves minus 12 halves.
Oh,
3 halves plus 9 halves. Oh, sorry, 3 halves plus 6 halves, I said it. Anyway, is there anything that we can do with this, or is it just going to be ugly? Nothing. It's just going to be fractions. So on the, how do we multiply fractions?
straight across.
Straight across. So the negatives cancel, and then we get 81 over 8. Let me write that better. 81 over 8. Okay, so our vertex, of course, is a point. So 3 halves, 81 eighths. Could you graph that? Where's 3 halves? 1.5. Where's 81 eighths?
10.
Yeah, just barely past 10, right? If you're graphing with a pencil, you probably won't even be able to tell much that it's past 8. So, excuse me, past 10. Guys, that's some of the details of intercept form. It says solve. This is intercept form. What are the zeros?
Negative 1.
It'd be positive 1.
Okay.
Be careful with sign. What are the zeros here? Okay.
Oh, there's
Are you seeing it? Is that working okay? Okay. What if I said graph? It says how can you find the solution? I want you to ignore that. How would we graph this? How have we graphed before? Where did we start? We started with the vertex, right? You can start with the intercepts. Where are they?
9
Nine.
and 2.
No,
Or 5.
negative 2.
Okay, so this is kind of what I was saying a second ago. Like negative 2/5 is somewhere in between, right? Like once you make your dot, it kind of covers a bunch of points. It's okay. All right, those are our intercepts. Which way does it open? How can you tell that?
If all the x's are positive, that means that it opens up.
A is positive 1, right?
Yeah.
What if you had a negative sign right there? Which way would it open?
Down.
Yeah, so be careful. You might have to like multiply the two x's just to check, because there might be a value inside there with it. So don't just pause and look at that, okay? Anyway, we know it's opening up. Let's find the vertex now. Where is the x coordinate?
9 plus negative 2/5 plus 2.
Okay, how many fifths is 9?
45.
45 fifths minus 2 fifths.
43.
So 43 tenths, which is roughly going to go where on our graph?
4.
Okay. Yeah, and I'm going to actually write this as well because it's all the same. Okay, so a little bit past 4. It's not like I'm going to grade you on how close you get it to 4.3, right? That's okay right there. Anyway, we know our x coordinate is on that line. Now we need the y coordinate. So 43 tenths minus 9 times 5 times 43 tenths plus 2. All right. Huh? How many tenths is 9? 90 tenths. So 43 minus 90 is what?
Negative 47.
No, 47.
Yeah, negative 47.
But negative. And then over here, the 5 and the 10 can simplify to 2. So this is really 43,
86.
43 halves.
Yeah.
Okay, how many halves is this?
4.
Okay, so 43 plus 4 is 47 halves.
I didn't know you could do
Okay? And I don't really know what 47 squared is.
It's negative. Calculator.
Yeah, it's negative, that's true.
47 squared.
40 squared is 1600.
Wow. Whoa. We should just call it there.
Divided by 20 would be,
It's
what is that, 80? Would be 80.
4.
Yeah, it's going to be. So we're just going to do this. Okay? Alright. How are you feeling about graphing with this form? You're not always going to get fractions. It's just the way the problems are working out. Give me a thumb on intercept form. You seem to be connecting with it well. Okay.
Like a 78%.
78%.
Like a C+.
I mean, if we just do that, like, for the test, I want to be feeling just about them all.
What does on the ground mean? Ground.
Zero.
What's 0?
When the ball hits the ground.
The x
What is
axis.
0?
The x axis.
There isn't a y. They finally wrote it in a good form. What's 0?
Where?
Y equals.
I'm saying when you go to solve this, what are you making 0?
X's.
Uh-uh.
Where you started at?
It's the height. The height is 0. On the ground, the height is 0.
Oh, yeah.
Right? How about this one? A baseball is thrown from the upper deck. Apparently we want to hurt somebody. What are we setting to 0 when it reaches the ground? H of x. That whole thing becomes 0, right? How do you solve that? What's your very first thing to do?
Yeah.
Look for a GCF, right?
And GCF of 6, 10.
Alright, I think we're good.
Bro, every single day, bro, I